In this video, we're going to start to look at the periodic trends on our periodic table. We've already talked about how the periodic table has a series of repeating patterns, and we want to start to go over some of the trends that we could observe. If you look at your reference table, the page after the periodic table, table S, has values for a lot of the trends that we're going to be observing. So we'll explain how it works in the video, and we'll discuss how and why the trend is happening. But know that if you wanted to, for example, look up any of these trends on your reference table, such as atomic radius, electronegativity, or ionization energy, we can do that in table S. So don't freak out completely when we're watching this. The first trend we're going to talk about is atomic radius. And atomic radius has to do with, you guessed it, the radius of the atom. So when we're talking about atomic radius, we're looking at how big is the atom. Radius we know is half the diameter, but it's hard to measure how big an atom is because we talked about this modern model. It's not this definitive edge. So what they do is they will put two atoms side by side, and we will measure the distance from the center of one atom, the nucleus, to the center of the other atom, the nucleus, and then we could take half the distance to get the radius, because the distance from center to center would be diameter. So we're going to take half the distance to get the radius. So here's a picture of what this would look like. If here's the nucleus of one atom, here's the nucleus of another. The diameter is across. That's something that we could be able to see using a scanning electron microscope. And then if we took half of that diameter, we'd be looking at the radius. So the definition of atomic radius is half the distance between two nuclei of adjacent atoms or adjacent molecules. The atomic radius is measured in picometers. Picometers are really tiny. So if you look at your reference table in the back in table S and we look at the values for atomic radius, when you see PM, those are picometers. And remember that you don't have to memorize what a picometer is unless you're taking the SAT too, because pico is listed on the front of your reference table. And we looked at that back in the beginning of the year when we were looking at measurement for the different units like kilo, deci, all that. That's all there. We could talk about what happens to the size of the atom, the atomic radius, as we go down a group. Remember, the groups are the vertical columns. And we could also talk about the trend that's observed when we go across a period. So first, we're going to look at a group. As you go down a group, you're going to keep adding an energy level. So the second row has 2 levels. The third row has 3 levels. The fourth row has 4 levels, and so on. Since there are more levels or more rings, the atom itself is going to get bigger. So what happens is you have electrons on those outermost electrons are attracted to the center of the atom, the nucleus, where the protons are. Every time you add another level, they're not going to feel that attraction to the nucleus as much because they're further away. So you could think about the attraction like magnets. If you have your positive and negative close together, you feel the attraction very strongly. As you move the magnets further apart, similar to as the energy levels are moving further out, it doesn't feel the attraction as much, so it doesn't get pulled in or sucked in almost as much, so it's going to stay further away. In addition, there's something called shielding. Shielding is that the electrons on the outermost energy are not feeling that attraction because the inner layers shield or block their attraction to the nucleus. So this first ring, ring 1, feels the attraction to the nucleus the most. The second ring still feels the attraction to the nucleus, but is shielded by the first ring, who kind of gets feel the attraction first, so to say. So it's kind of like when you go to a concert. If you're in the second level, you have the people in the first row or right in front of you kind of blocking your view. That's why the first row typically in any arena would be the most expensive, because they get the closest feeling to the nucleus or the closest attraction. So as you go further away, these inner electrons are going to block your attraction to the nucleus. That's part of the reason why you don't feel that positive attraction as much. So as we go down the atom, as we go down a group, the atom size increases for 2 reasons. One is that it's physically adding another shell or a ring. And the second reason it gets bigger is because the inner shells shield your attraction to the nucleus, so you don't have as much attraction, so you're not pulled as tightly inward. We talked a little bit in the POGIL about how this is called Coulombic attraction. It's that same idea. As far as the periods, remember the periods are the rows going side to side. As you go left to right across the periodic table, you keep adding protons. So here's my nucleus. I keep adding protons into the nucleus, but I am within the same shell. So I keep adding protons they are going to pull on those electrons stronger. So every time I add a proton, it's like adding an additional magnet, pulling those electrons in. So add a proton, add a proton, add a proton as we're going left to right, because remember the proton number is going up. So as you add the protons, these electrons get pulled in tighter, making the atom smaller. So as you go left to right, the size of the atom actually decreases or gets smaller because these electrons are being pulled in due to the increase in protons, which we're going to say is an increase in nuclear charge because the protons are in the nucleus and are providing all that positive charge. So we're in the same level. We don't have any additional shielding as you go left to right because we're in the same, it'll experience the same shield whether you're all the way on the left of a period or all the way on the right of the period because you're in the same ring. So whether I sit at, like, let's say the 300 section in Nassau Coliseum over here or the 300 section over here, I have the same obstruction, basically, is the way you might want to think about it. So the same amount of shielding as you would on either side. It's not more shielding. It's just that there's more protons, so they're pulling your attraction in more and making you feel the electrons being pulled in tighter to the nucleus. So to recap, the atomic radius is really being influenced by two factors. The principal energy level for the groups, meaning that as you go down, you're getting bigger because you have more energy levels. And for the periods, the side to side, you're getting a greater nuclear charge, which is pulling the electrons in closer. So let's just look at a period trend so that you can see what this looks like. Here we're going across the period. So NA all the way on the left, MG. So this is, if you look in your reference table, you'll see where we are. We're going left to right across the period. What's happening? We still have the same number of shells. We're in the third period. So every one of these is going to have 3 numbers in its electron configuration, or 3 rings, or 3 energy levels, however you want to say it. What happens is we're starting with Na, which has 11 protons, 12 protons, 13, 14, 15, 16, 17, 18. We're adding more protons. Those protons are going to pull the electrons on the third shell in tighter and tighter as we go side to side. So as we go from left to right, rather. So this is a picture showing you what happens as we go across the period. For the group trend, as we go down a group, we're adding an energy level. So 1 ring, 2 rings, 3 rings, 4 rings, 5 rings. You see that the atom is getting bigger because you're physically adding another ring or another energy level to the atom. We also talked about the fact that you have shielding. So shielding is going to make the atom get bigger because it's not going to feel that attraction to the nucleus as much. So you might want to think about, if you're attracted to somebody, you want to be close to them or near them. So when you increase the attraction, the electrons and protons come closer to each other. If there's less attraction, for example, all the way down here on rubidium, the electrons on the outer ring do not feel the attraction as much, so they're further away. And here's a picture of the periodic table. If you look, you see as we go down the groups, we get bigger, bigger, bigger. As we go across the period, we're getting smaller. Across the period, we're getting smaller. Okay, we'll stop here because Sean's asking me to stop the video.